Okay, let's now take a look at the model that we will build. So remember, we're going to start from these medium resolution JPEG files, 150 by 150 pixels with 3 channels because it's a color image. And then we have a first convolution layer, and the filter that we will use will be a 3 by 3 filter. Yeah, so here we're going to use a 3 by 3 filter. Yeah. And remember the formula, because this image is going to be reduced in size. Remember, it's n minus f plus 1. So in our case, f is 3, n is 150, yeah, and we need to add 1. So 150 minus 3 is 147 plus 1. Yeah. So the images in this case will be 148 times 148. Yeah, and times, 32. So here we choose to have 32 filters, right? And then we're going to use a max pool, and the max pool is going to be a 2 by 2. And remember, a max pool halves the size of the image. So here you're going to go from 74 times 74 times 32. Now remember, a max pool halves, yeah, but keeps the channels, keeps the number of filters, yeah, and doesn't create any parameters, doesn't create extra parameters. Alright, so and then we will take a second conv layer, yeah, and here of course you have the same. N is 74, minus 3 is 71, plus 1 is 72. Yeah? So the output here, and it's again a 3 by 3, and the output here is so 72 times 72, and here we're going to use 64 filters. So these are choices that we as data scientists make. Yeah? And you see that basically the size of the image is shrinking, but the number of filters we use is going up. And we go from 32 to 64. So here again we're going to do a max pool 2 by 2. Yeah? And so this size is going to go to half. So it's 36 times 36 times 64. Alright? So now we're going to have a third convolutional layer. Yeah? And so n minus f is 36 minus 3 is 33. So it's going to be 34. Yeah? In this case you're going to have 34 times 34 times 128. Yeah, so again we double the number of filters. Yeah, and here again we're gonna max pool with a 2 by 2. So the end result is gonna be that we have a 17 by 17 times 128. Okay, so let's take a look at the next layer now. So we have 17 minus 3 is 14 plus 1. So this is going to be a 15 times 15 times 128. So here again we use 128, which is the same as the previous Covnet layer. So here again we will max pool 2 by 2. So we divide this here by 2, which would be 7.5, but of course we can't work with halves. So we're going to use 7 here. So this will be a 7 times 7 times 128. So here you see you go from 150 by 150 to a 7 by 7. Yeah, the number of channels is increasing. The size of the image is decreasing. So then we have a flattened layer. Yeah. So the flattened layer, what it basically will do is, here you have your image, right? And the image is a block of numbers. Well, basically flattening is going to convert this into a linear structure. If this is layer 1, this is layer 2, then actually you're going to convert it into a sequence, a linear structure that you can actually feed into the fully connected layer. And here the fully connected layer will have 512 input units. So this whole stream is going to go through all these 512 units, and then at the end you will have a sigmoid with two outcomes. One is cat, one is dog. Yeah? It doesn't give you the output, cat or dog, but it gives you the probability of it being a cat or a dog. Alright, so now we're ready to start our coding exercise.